Hi everyone, today's math lesson is a review of lesson 5.4. So what I want to have you do is find your journal and you're going to turn the page. So the last thing we learned was how to convert the remainder into a decimal. Then you're going to turn the page and it should be the back side of that page that we're working on. And we're just going to, we're just going to write over here on the side the date. So you're going to still let's just put the date box above the hole right there. So we're going to write the date, and we're going to have lesson 5.4, and then you're going to write C-O-N-T, and that means continued. And then I'm going to use purple, since we didn't get to use purple in our last lesson when we pulled it out. So 5.4, continued, is what this means. Okay? And we're actually not going to put a title on it at all, because we can look back to 5.4 to know what that was. And I want you to find in your math workbook, this is the second edition, make sure you're in volume 2, and I want you to go find page 201. Again, go find page 201, where it says Unit 5, Lesson 4, and it has a blue toucan bird in the top right corner. Get your name and number on it, and flip it over and get your name and number on the back side. Pause this video until you have that done. All right, so we had page 201 ripped out of our workbook. What we're actually going to do is put our journal to the side, but we're going to keep it out so that we can refer back to it to our notes for what to do when we're dealing with remainders. And we're going to go with page 201, and we're going to turn it actually and do the back side first, which is pretty interesting. We're going to do some of the harder ones first, okay? So let's work with that. It says, decide what to do with the remainder continued. Sometimes you use a decimal number instead of the remainder. So remember, we were using decimal numbers with the last part of our lesson. So I like the example that they give here, but I want you to not really be focused on it. So I kind of want us to, well, actually it might be good for us to look at it. Let's just take a look at what they've done. Suppose 16 friends earned $348 at a car wash. They want to divide the money equally. Will you put the word divide and equally in purple? I'm just going to highlight it. And what else kind of tells us we might be dealing with decimals is this word right here, money. So they want to divide the money equally. The division at the right shows that each friend gets $21, and then there are $12 left over. Okay, so this is what they're saying. So they each get $21, and then they had $12 left over. And then they kind of take it to a situation where they did fractions, and then they converted that to $1. But I want to go into this blue box and show you how they could have just done the decimals with dropping down the 0. So it would look like this, right? There's a decimal in the quotient, and you put a decimal in the dividend, and you drop down the 0. So it says 120 down here. And 16 goes into 120 7 times, probably, because they put the 7 up there. Let's just prove it up above. That would be 112. So it did work. So it was 7 times. They already did that. But I minus 112. Make sure your leftover, which is 8, is smaller than 16, and it is. And we should extend this answer line, the quotient line. And here's the situation where you're going to drop down another 0. And it's 80. And 16 goes into 80 5 times. Let's prove it. It is 80, so I'll subtract it to prove that the answer was $21.75. And if I'm dealing with money, then each friend would get $21.75. Isn't that so cool how it works? I love it so much. Here's another super cool thing. Look at this real quick. When I got to the number 8, so I did 120 minus 112, and then I got a leftover of 8. Before I drag down that second 0, I did a quick check because always after you're done subtracting, you should check with the divisor to make sure that it's smaller than that. So I took the 8 and I subtracted it from, well, I took the 8 and I went, is it smaller than the 16? Yeah. But then my brain did something else super cool. It did this. Well, 8 is half of 16, right? Yeah, 8 is half of 16. So what decimal do we use that represents half? Do you know? It's 0.5. It's a 5. So look at what it ended up being up here. A 5. So in the situation when you get a leftover and you're about to drag down another 0, you can just look over the divisor and say, is that half of that? And if it is, then you know on the quotient it's 5. It's pretty awesome. We'll try to find another one that works like that. But anyway, let's move on. Number 4. A rectangular garden has an area of 882 square meters. The long side of the garden has a length of 35 meters. How long is the short side? Okay, we are doing measurement. And do you remember that we talked about in our journal? I'm going to show you one reason why we might need to be dealing with decimals as our remainders is if we're dealing with types of measurement, length and width. And we are. So let's go ahead and set up this problem just like long division over here. Let's do it like this. 882 divided by 35. Here we go. 35 won't go into 8, so I place an X. 35 will go into 88, and it goes in twice because 35 times 2 is 70, and I know I'm not going to get another 35 out of that, so I'm just helping you. It goes in twice. 35 times 2 is 70, so I subtract 70. I get 18. Is 18 less than my divisor? Yeah, so it's good. I bring down the 2. 35 into 182, I have no idea. Well, but 35 times 2 was 70. So if I doubled that, 35 times 4 would be 140. So it's got to be more than 4. Think it could be 5? Let's try a 5 right up here. Did I do that right? Did you get 175? Okay, so it works. So 5 is up here in the quotient line. 175 gets subtracted. And it's a 7. I'm trying to give, you're not going to say it's 25 and remainder 7 meters. And if it's measurement, I want you to practice trying to do it with the decimal. You could say it's 25 and 7/35 of a meter. But let's practice the decimal thing. So decimal in the quotient, decimal in the divisor, drop down a 0, extend the division line, sorry, the quotient line. 35 goes into 70. Oh, exactly 2 times. We did that before. So it's 2. And once you get left with 0, you are done. So 25.2 meters is how long the short side is. Well, it is 25.2 meters. It's pretty awesome. Let's go ahead and use purple to show that drop down 0 and how it worked for us. So awesome. All right, number 5. Sometimes the remainder is the answer to the problem. Cool. A bagel shop has 138 bagels to be packed into boxes of 12 to be sold. The extra bagels are for the workers. That's cool. So how many bagels will the workers get? So we're looking for the extra, which means the remainder. Please write this on your paper. So I have to do the division in order to know, sorry, in order to know how many there truly are as the extra. So if I'm ready to do that, I go like this. 138 divided by 12. And then I'm looking to find out what my remainder will be. I'm going to come over here. 138 divided by 12. 12 goes into 1? No. 12 goes into 13? Yes, one time. What is 12 times 1? It's 12, so you subtract 12 from 13. You bring down the 8. This is pretty easy. How many times will 12 go into 18? Only once, because twice would be too many. So subtract the 12. Now, in this situation, I have a remainder. So I'm going to be able to pack 11 boxes. But then I'm going to have 6 left over. This is not a situation where I do a decimal, even though it's pretty cool. Because 6 is half of 12. I wish I could just do 0.5, but it's not. So that's not going to work exactly. So if I'm in this situation, what I have to do is I am going to think about the problem. The question is, how many bagels will the workers get? The workers get the remainder. So the workers are going to get 6 bagels. They will get 6 bagels. Why is the remainder the answer? It's pretty simple, right? Because the workers got what was left over. And 6 were left over. That's pretty great. Okay, number 6. At the Cactus Flower Cafe, all tips are divided equally among the waiters. Last night, the 16 waiters took in $1,108 in tips. How much did each waiter get? This is a real life situation, my friends. This happens all the time with money. If we're dealing with money, we're going to be doing a decimal. Remember? So we take the total amount, 1,108. We divide it by the 16 workers. There we go. Will 16 go into 1? No. Will it go into 11? No. Will it go into 110? Yes. I don't know my 16's timetables, but I can do 15, okay? Or I could just go, well, if I could just go, it's kind of close to 20, 20, 40, 60, 80, 100. Like you can round it to 20 if you want. I'm going to round it to 15 because I know that 15 times 6 is 90. So 15 times 7. Should I try 16 times 7 or 16 times 6? Let's try 6, and we're going to work up above right here. That's only 96. I could probably get 16 more, so dang it, it was 7. Oh! It's not 7. Oh, it is 6. That's so interesting. 7 was too high. Did I do that right? Yeah. So it is 6. 16 times 6 was 96. You got to line that up. You can't put the 96 over here. You have to put it with the 6. Subtract it. $14 is left over. Is 14 less than 16? Yes. So I bring down the 8. And I start all over again. Well, I know it's going to be more than 7. Do you think it could be 9 maybe? Should we try 9? Nine would be 144. Yeah, it's 9. So 9 is in my quotient. I subtract 144. They don't get $69 remainder 4. That's not how it works. So you do the decimal thing. Here it comes. It's the best. Put a decimal in the dividend and the quotient. Extend the quotient line. Drop down a 0. And start over. 16 goes into 40. I don't know. Is it twice? I think it's twice. Let's try 16 times 2. That's 32. So yeah, it's twice. So 2, subtract. What is 40 minus 32? It's 8. So I go to bring down another 0. Well, first I check. Oh, 8 and 16. What do you know? 8 is half of 16. So the next number up here is the 5. And it is, because guess what 16 times 5 is? It's 80. So let's pretend you didn't know that. The little trick Miss Fisher taught you. You would have dropped down another 0. And 16 times 5, we're going to have to do it up here, is 80. So when you subtract 80, you get 0. Pretty awesome. So how much did each waiter get? $69.25. Pretty great. Okay, we are not going to do number 7. Sorry, we don't have time. Turn it backwards to page 201. Decide what to do with the remainder. Okay. Let's actually go ahead and get a pair of scissors out and a glue stick, because I actually want to cut this out and glue it in before we start solving, so that we know exactly how much space we have to deal with. So turn in your journal to the 5.4 continued that we made and get it ready with a glue stick and scissors. And what I'm going to do is, we did all of that work on this page, so you have to have all of that work done. And what we're going to do is, where it says decide what to do with the remainder, we're going to keep that but cut really close to the numbers on this side. So I'm just cutting off the margin. I actually do want the title, decide what to do with the remainder. I want that. So keep that, but cut off your name. And cut off anything extra that we don't need. In fact, I don't even want this blue thing. I want us to have to do the work. So cut that off. Go all the way to the lines is what I'm saying. Okay, you see that? So I have a long, skinny set of problems. I take the extra scraps and put it to the side for now. I'm going to glue it in my 5.4 continued journal page. Now, don't put it right here in the middle. I want a lot of space to do the work. So put it up here to the, oh, you know what? I don't need this content standard Common Core stuff at the bottom. It could be even shorter. Okay, let's put it like at the top left, so we give ourselves plenty of space where we could even work underneath it if we wanted to. So we're going to put it, again, at the top left. Get it glued in there. Keep your purple out. I'm actually going to glue. I've been taping lately, but this time I'm going to glue because it's nice and straight. Should work out just fine. Make sure it's sealed down. I'm putting it in the top left of the page. Smoothing it out. Okay. If you are behind, you got to push pause on the video, but we got to move on. All right. It says, think about each of these ways to use a remainder. Sometimes you ignore the remainder. Okay, so they've already told us we're going to be ignoring this remainder. Let's do the work over here to the side. A roll of ribbon is 1,780 inches long. It takes 1 yard of ribbon, or 36 inches, to wrap a gift. How many gifts can be wrapped? Well, you don't take 1780 or 1,780 divided by 1. You take the inches divided by the inches. So we're taking this number and dividing it by 36. So 1780 divided by 36. And I'm thinking for, what's the question? How many gifts can be wrapped? Okay. 36 won't go into 1 or 17, so those both get X's, but it goes into 178. I have no idea how many times, but 36 is close to 40. And 40 will go into 178. Well, 4 times, sorry, would be 140. I bet I can go 5 times. Because even though that'd be 200, for 36, it's not going to be 200. I say we try 5. Let's try 36 times 5. Oh, dang it. Oh, I was so close. 180 is so close to 178, but it doesn't work. Dang. It has to be 4. I'm just going to do it right here. $144. Subtract it. Make sure your leftover is smaller than 36. Ooh, it barely is. That makes sense. Because I was only off by 2 on the 180. Right? I was off by 2 to get 178. And then I'm only off by 2 with my remainder because I had to drop down. Anyway, bring down the next number. 36 goes into 340. Ooh, probably a lot of times. I'm going to say 8 or 9 times because it's going to be double that. I bet it's 8 or 9. What do you think we should try? 8 or 9? Let's try 9. I'm sorry if it's not 9. Right? Is that right? 6 times 9 is 54. What am I doing? Wow, I was going too fast. 6 times 9 is 54. That's 27 plus 5. 32. Is that right? 54. Yep. So it worked. So 9 times 324. Okay. 16's left over. I'm not looking for a decimal here. It's how many gifts can be wrapped. You could wrap 49 gifts, and then you're going to have some leftover ribbon. Right? So in this case, we're ignoring that remainder because I want to know how many gifts can be wrapped. So how many gifts can be wrapped? 49 gifts can be wrapped. And then the question is, why do you ignore the remainder? Because there isn't enough to wrap another gift. Comma, it is leftover. Is it ribbon, right? It is leftover ribbon. That happens all the time. Is it ribbon or wrapping paper? Ribbon. Okay. Okay, the next one. Sometimes you round up to the next whole number. Oh yeah, round up. Because you can't leave people out. There are 247 people traveling to the basketball tournament by bus. Each bus holds 52. So the word each and holds are good division clues. So I take 247, divide by 52. And it says how many buses will be needed. So when we get to the end here, we're going to see, are we going to leave some kids out or are we going to have to get an additional bus? This happens all the time with traveling and buying things. So let's come up here because we're going to run out of space down here. Let's come and do our work up here to the right. 247 divided by 52. $52 won't go into 2 or 24, so it just is going into 247. And 52 is really close to 50. So 50 times 5 is 250. It can't be 5 times. It's going to have to be 4 times. So I'm going to do the work here. 52 times 4, 208. That worked. Make sure that you didn't get a remainder that is more than your divisor. What is 17 minus 8? 9? Yes. Okay, so if I get 4 buses, then 39 people will be left out. They'll be so sad. So I have to round up or add 1 to the 4 in order to get enough buses. That's important. Let's do that with an arrow, a purple arrow, sorry. You gotta add 1 more. So how many buses will be needed? 5 buses will be needed. You know what? I think I spelled buses wrong on the previous journal day. Sorry about that. Maybe we should fix it later. Okay, you only have 1 S for buses. I think I put a 2 there. Weird. 5 buses will be needed. Anyway, why do you round up? Because you can't leave anyone out, especially people playing in a basketball tournament. They'd be so mad. Because you can't leave anyone out. Okay, step number 3. Sometimes you use the remainder to form a fraction. This is our mixed number. That's the one we learned that was yellow, mixed number. So the 28 students in Mrs. Colby's class will share 98 slices of pizza equally. Share equally. So that means with food, remember, you can do this. You can cut things up into smaller pieces or break them or split them. So this is a perfect example of when you would use a fraction. So they have 98 slices of pizza, and they're going to split them between the 28 students. So you do 98 divided by 28. 98 divided by 28. 28 is really close to 30. It's not going to go into 9, so you're just looking at 1-step division right here. 30, 60, 90. That's 3 times. Could it be 4 times? No, I think it's going to be way too many. So let's try 3. Do 28 times 3. Make sure it will work. Keep going. Is your leftover smaller than the divisor? Yes. It's 3 remainder 14. But remember, it says how many slices will each student get. So they're all going to get 3, and then they're going to have to take these 14 and cut them up smaller to get enough, right? If I was doing decimals, it would be really cool because it'd be point. And then what is 14 and 28? Do you know the cool connection there? That's exactly half. So it'd be 0.5. They'd get 3.5 slices. But we're looking for a fraction. You should know what 0.5 is as a fraction, though, too. It's 1/2. But you don't know that yet. So let's say that you just go like this. Okay, 3 remainder 14. That doesn't make sense. You can't have a remainder of a piece when you're giving out pizza. So you change it into a fraction. 3 and 14/28. Well, you need to simplify that. They can both be divided by 14, and that's going to give you, my friends, 1/2. So they get 3.5 slices of pizza. How many slices will each student get? Each student will get 3.5. I'm actually going to say slices of pizza. And the next, look at the division shown here. Explain how to get the fraction after you find the remainder. Okay, so after we found 14 as the remainder, what did we do? The remainder becomes the numerator. We'll just say the remainder is the numerator. Period. The denominator is the divisor. We've been saying this for a long time. Then I simplified. We'll say then I simplified the fraction. So the remainder is the numerator, the denominator is the divisor, then I simplified the fraction. Oh, division is just the best. I love looking at remainders, and I hope you have learned and practiced a lot of it, because now you are ready to do the homework side. That's it for the math journal today. That is it, friends. Just this one. Congratulations. You can put your math journal away, or you can save it because it has some really helpful practice problems, hint, 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 and some really cool steps to remember from the previous days. So you can save your journal out, but if you pull out your homework, which you should already have, since you did remembering last time, since you have 5.4 homework, look at what happens. There's only 5 problems here. But the deal is that you have to read the problem, solve it, and circle what you did with the remainder. So did you use just the quotient? That would mean whole number only, quotient. Did you round it up by 1? Did you change that remainder into a fraction? Did you do the decimals? Or did you only look at the remainder for your answer? So there are 5 options and there are 5 problems. So do you think that maybe there's one of each kind? I don't know, you'll have to find out. Maybe not, maybe one gets repeated. I really don't remember. So today's assignment is for you to finish homework 5.4, and you have a Think Central assignment today. So last time we did the remembering side, which looked like this, and that's all we had to do because the journal was so long. But today we're doing the homework side and Think Central. Everybody needs to log into Think Central. So enjoy it. Thanks for hanging in there, and hopefully you learned something about remainders.